All right, hello, here is the last official lesson for 5-3, which is on slope and rate of change. So this first part is just reminding you that slope is a ratio that measures how steep a line is. The bigger the number that you get, the steeper the line is. So we can find slope by comparing the rise to the run. So in this case, okay, they're showing here to get from this point to this point, we're going to be going up and right, which are both positive directions, okay? So here we are going up 3 and then right 2. So our slope is going to be 3/2. All right, so here in this problem we have a question that says find the slope. So I just wanted to point out that if you do not have dots on your graph, you still should be able to find the slope. It's just going to be a little bit more difficult because you have to put the dots on there yourself. How do you know where to put the dots? Well, that's where the line is going to cross through any of these intersection points on the graph easily and nicely. So for example, I could also pick this point on the line, excuse me, because this point goes through a nice T intersection on the grid. Okay, another place that I have that on the graph is here. So you can pick any 2 points on the graph that you want to in order to find your slope. Sometimes they'll give you the dots and sometimes they won't. You might have to put your own dots on the grid. Okay, so in this problem here, they're showing going left to right, and they're showing this kind of an interesting way. They're showing it on the right side. I like to always describe my rise first, so I'm just going to draw it on the other side, on the bottom side of the line. So to get from this point to this point, we have to go down 2. Okay, and down is going to be a negative direction, so I'm going to put a -2. You know what? That's 3. That's the hardest part of slope, isn't it? It's like just counting the numbers. Okay, so here's 1, 2, 3. So we're going down 3, so that's a -3. And then our run is actually just 1. We had to go to the right to get there. So we had to go right 1. So if I were to simplify this slope, that would be a -3. Okay, so the next one, up or down. Here they gave you the dots, another spot that might kind of work out. You can see it approaching here. Here's another spot where it's going to go through a point on the grid perfectly. All right, so again, I like to do the rise first. So to get from left to right, I'm going to go up and then right to get there. So I'm going up and then right. Up is the positive direction. We're going up 1 unit. And then right, we're going 1, 2, 3, 4 units over. And right is also a positive direction. So it's going to be positive 1/4. And when you're all done, I would go back and just check all of your slopes and see if they make sense. If it's going down, you should have a negative answer. And if it's going up to the right, you should have a positive answer. Okay. So the next one says, explain how you can use the point 2, 3 and the slope of 2 to draw a line, which is some of what you did yesterday. So the first thing that we have to do is we have to plot the point that they give us. All right, so if I were to do that down here, I don't think they're giving us room to. Nope. Just going to kind of draw a quick grid on here. Okay, so if I start with 2, 3, from the origin, the first is my x, so I'm going to go to 2 and then up to 3. Okay, so there's my point. Okay, the next thing I have to do is from that point, so I'm going to start at 2, 3. I'm going to go and use my slope of 2. Okay, and 2 if I were to write that as a fraction, is 2 over 1. So that means my rise is 2, and it's positive, so I'm going to go up 2, and then I'm going to go right 1, because 1 is also positive. Okay, so from there, I'm going to go up 2 and right 1, and I'm going to put a dot. Okay, now you can just connect these with a straight edge. I always say that you should have 3 points on the graph before you can draw a line through them. So on this graph, I can't go up 2 and over 1 anymore. So I'm going to do the opposite. What's the opposite of going up and right? It's going down and left. So I could also go down 2 and left 1 from my original point, down 2 and left 1, and that will also be a point on the line. Okay, so step 3 is always to connect those points. Okay, so there's my line. Okay, the next one is interpreting rate of change or slope on a graph that's a real life problem. So the question says, how much does Jerry earn per hour? So on the graph, Jerry is the solid line. So I want to know how much he makes in 1 hour. So what I'm going to do is for 1 hour, I'm going to find that on the x-axis. I'm going to follow that up to Jerry's graph and then over across. Okay, so Jerry makes $8 per hour. Okay, per hour means, remember that's like a unit rate. So this is in 1 hour. Okay, it says, what is the slope of the graph that represents Daniel's rate of pay? And how much does he earn per hour? So to find slope, okay, we have to find 2 points on the line. And this is exactly what I was telling you before. Sometimes you're not going to have dots on the line. So we have to find a spot where it goes through a point perfectly. So 0, 0 is always a nice point to pick if it goes through 0, 0. And here it does. It's very easy to see that. Now we're looking at Daniel's graph. So if I look at 1, it doesn't go through like the line up here very nicely at 1. At 2, this line is between 8 and 16. At 3, it's a little higher, but at 4, it goes through 24 perfectly. So I'm going to pick this as my other point to calculate the slope. Okay. So now to do slope, again, we have to do rise over run. All right, so rise over run. In this case, okay, my rise, be careful of what we're counting by on the y-axis. The rise is $24. And the run, if I go all the way over, that's 4 hours. Okay, so if I were to simplify that, that would give me the simplified slope, which is actually also going to be how much Daniel earns per hour. So 24 divided by 4 is going to be $6 per hour. Finding the unit rate is the simplest slope in this case, and it tells you how much he earns per hour. Okay, the next one says Jerry and Daniel each worked 10 hours this week. How much more than Daniel did Jerry earn? Okay, so we need to go back to these to figure out how much they earn per hour. So if they each worked for 10 hours, so for Jerry makes $8 an hour, and he worked for 10 hours. So if I multiply those, Jerry's rate or Jerry's earnings would be $80. Okay, Daniel makes $6 per hour, and he worked for 10 hours. So that means he earned a total of $60 in earnings. Okay, so what I have to do is figure out how much more than Daniel did Jerry earn. To figure that out, I'm going to subtract the 2 amounts of earnings. Okay, so my final answer here is $20. All right, this one we're just not going to worry about. The next one says choose the letter of the best answer. So 8 and 9 have to do with this graph. All right. So it says the graph shows the changing height of two rockets over time, rocket A and rocket B. Use the graph to solve these problems. So which statement is true? All right, both rocket A and B have a constant rate of change in height. So yesterday we talked about how constant rates are lines. Rocket B did have a constant rate, but A does not. So it can't be this one. Okay, B says A and B both have a variable change. Well, A has a variable change, but B has a constant change. So it's not this one. All right, this one says A is variable, which it is because of the curve, and B does not have a variable rate. That's the one right there. Okay, it says rocket B has a variable rate for part D. B does not. It is a straight line, so it is constant. All right, how fast is the height of rocket B increasing? So we're just looking at this line right here. So to figure that out, we can calculate the slope. So again, we need 2 points on the line, and it doesn't matter what 2 points you pick. All right, so 0, 0 is always a nice one to pick, and then you could pick anywhere else that the line crosses through the grid really nicely. So for example, you could pick this point right here, or you could pick this point right here, or even this point over here. So all we need is 2 points. So to figure out the slope the most effective way, I'm just going to find the slope between the two closest points. So I'm going to start down here from this point, and I'm going to count rise over run to the next point. Now, rise over run is going to be the same for each one of these. We talked about this the other day, how it's like a staircase, right? Rise and run are always going to be the same. So here, if I were to count the rise, that is 20, right? And then the run going across from this one is 0 to 2, which is a difference of 2. So 20 over 2 is our rise over our run. And 20 over 2 simplifies down to 10. So that rocket is accelerating at 10 feet per second. All right, this one has nothing to do with the graph. It just says Jamal plotted a point, and then he used a slope to find another point on the line. Which point could be the point that Jamal found? So I'm going to do this by actually graphing a line. If I were you, I would do this on actual graph paper. I'm going to just take my time and draw a nice straight grid. Okay, so when we do these problems, we always start with the point that they give us, which in this case is +1, -2. Okay, and then we're using a slope of -2 over 3. Now the negative sign is out in front, so technically we could have it on top or on bottom. I just like to think of it on top because I always like to go to the right. So if the bottom number is positive, that means that's how many that I'm going to go right. The top number, okay, so we're going to be going right 3, but the top number is a -2. So since that's negative, we're going to be going down 2 and right 3. Again, the top is the rise, so up or down. Since it's negative, that's down. So from this point, I'm going to count down 2 and then right 3. And then I could do that again, down 2 and right 3. I'm going to ignore the phone. Okay, so here was my original point. So is -1, -1 a possible point on the line? That looks possible. Is 4, 0 a point on the line? Absolutely not. 4, 0 is out over here. Okay, how about 2, -3? So 2, -3 is down here. It doesn't really look like it, but it's possible. And 4, -4. So if I look at this point right here, that's 1, 2, 3, 4, and then 1, 2, 3, 4. So this point actually is 4, -4. If we were to graph this on graph paper, it would look even better and you would definitely be able to tell. So I recommend that. All right. Again, let me know if you have any questions. I'm happy to help at any time. Good luck, guys.